Okay, so this is the next part of the video where I'm going to try to give you some of that pre-lab work that we would normally do in person. I think this will still work for us. So we are going to talk about the vitamin C titration, and there's two major things that you're going to do in this lab. First, you need to figure out what the concentration of the titrant is. That's the up top stuff. And once you know that, then you're going to use that titrant to figure out the concentration of some unknown sample. So two different parts there. Here's the titrant. Okay, I have lots of things labeled on this, but this is the most important thing right now. It says ballpark concentration 0.005 molar. KiI2, so potassium iodide and iodine, the Brinkelhoff. But it's only a ballpark concentration. This is really common, and so like there's a world where I could figure this out and just tell you exactly what it is. But this is really common in real life that you would have to be really confident about your titrant. And so this is some of the pre-work that you would do. So this is how part one is going to work. This is day one of the lab. And you should jot big notes, like kind of procedural type things, so that when you get together with your group, you have some idea of kind of what your strategy is. So these are supermarket vitamin C tablets, and we are going to pretend that these are highly accurate just to get the point across for what we're doing. I'm sure they're not particularly accurate, but these vitamin C tablets say that there's 1,000 milligrams, so 1 gram of vitamin C in a tablet. Now the tablet is going to weigh more than 1 gram, because when they make the tablets, they also have to put binders in, things that keep it in a nice tablet form. It's not just pure vitamin C. So here's one of those tablets. So your process is going to be to get a known quantity of vitamin C out of this, assuming that this contains 1 gram of vitamin C. So what you're going to do is you're going to weigh the tablet, and you're going to get an idea of how much is in there, and you should immediately be able to get a proportion out of that. So there's 1 gram of vitamin C per however many grams of tablet. Then what you're going to do is you're going to take a mortar and pestle, and you're going to grind it up, okay? And you're going to assume that this is uniformly mixed in here, and so that it holds that same proportion. And you're going to be able to take a sample of that powder and dissolve it into a known quantity of water. Vitamin C is highly soluble, and so you're going to be putting some amount of that you need to determine, some mass of the tablet, a fraction of it, into something like this. And use your good lab practice. Remember, you would put in the powder, then you would fill up a fraction of the way, you would stir it around, and then you can fill to the mark. The tablet in its powder form, that binder is not going to dissolve. And so you're going to see some, I think it's a little bit yellow from the vitamin C actually dissolving, but then there's going to be some floaties up here as well that's part of the binder. And there's just nothing you can do about that. That's not vitamin C that's sitting there, that's the binder. So the vitamin C is very soluble. So it is in solution. Okay, so once you have this, it's very easy to work quantitatively and to know exactly how much solution. So at this point, you're doing the molarity calculation or grams per liter, whatever you want to do, but you're figuring out what concentration of vitamin C is in this. So some grams per milliliter, whatever units you want to be in. Then you can quantitatively, either using these guys or whatever device you want, you can load up a sample of vitamin C of a known quantity in the bottom of an Erlenmeyer flask. Okay, so all of this, so you're grinding up your sample, You're pulling out some powder, you're tracking how much vitamin C should be in that, you're dissolving it, and then you're getting to a place where you have kind of a processed bit of liquid or dissolved vitamin C in this liquid. Then you're going to load up an Erlenmeyer with, again, a known quantity, like some amount that you want. So now you're going to have your sample and you're going to titrate it with this guy. Okay? So here's the thing. Again, ballpark, this is 0.005 molar. And you need to do the calculation so that you can approximately have the right amount of vitamin C in here, based all the way back from the 1 gram per tablet, so that when you load up your burette, that you're going to use approximately 25 milliliters. Okay? And it's kind of like we've done some work like this before where you're trying to pre-adjust so that you have about the right ballpark of stuff. All right. So I gave you the process that's going to happen on day 1. The math needs to start backwards. Start with the knowledge that this is approximately 0.005 molar, and it's I2 and I minus, Ki in it. And you want to use approximately 25 milliliters. So you got to figure out how much titrant is that, and what would be a good amount of vitamin C to match that amount of titrant. And so the calculations have to go in the reverse direction so that in day 1, you know how much vitamin C you should be pulling from this. Okay? And that's not trivial. So that's part of the homework, is for you to figure that out before you come in to lab so that we can have a smooth running lab. All right. Let's talk a little bit more about this titration though. Okay, here, remember this from the previous video that I had. I'm about to talk about these 3 things. The indicator, the sample is the vitamin C, and then the titrant is this stuff here. So here's what the titration looks like. Here's the actual chemicals associated with it. So this is vitamin C. You're going to need that molar mass at some point. Notice that this is a 1-to-1 reaction, so at least the stoichiometry is nice and easy for us. But you will need the molar mass of this so that you can figure out how many moles of this is in 25 and anticipated 25 milliliters of this approximately known concentration. So that's going to be the number of moles of that I would want. And then you got to figure out how much powder you're adding effectively so that you can achieve that amount, so that you can eventually find the actual concentration of this. And hopefully it's close to what you think it is. Okay, so here is the I2. This is the titrant. This is the important stuff, okay? This is what's in the burette. And here's my sample. This stuff I don't really care about, okay? This is what happens after the vitamin C reacts with the I2. And you can see what happens is it loses 2 hydrogens, and it's got these little H pluses over here, and then it makes some iodine. Now this is okay, this is good, because look at the secondary reaction that's going to give me my color change. What I have to do is I have to have starch in there, so we're going to call that our indicator. Here's the extra T, the titrant, right? That once that titrant is done reacting up here and now is available to react down here. But I also need some I minus around, because what it does is it forms this weird complex. So this is one big pile of potato starch and this I3 minus polyatomic that you've probably never seen before, but that's okay. It comes from I minus and I2. And the I2 is what we're adding. You can see that I actually make a little bit of I minus up here, which is good because I need the I minus also down here. What we do is I have also put in a significant amount of Ki into this, okay, potassium iodide, so that I can ensure no matter what, we have enough I minus around. So we're gonna make a little I minus. I need a little I minus. I put some extra I minus in there, so we're not gonna have to worry about that. So this is the guy that we are really worried about, and we need to know how much of this is in the titrant, and that's why you're doing part A. All right, and then this has a big color change associated with it. It's very potent. So here's what you're gonna do. So here's my ring stand, and then this is a burette clamp. The middle part of the burette clamp goes down. There's this little nut thing here so that I can tighten it. So I tighten that in. Okay, so it's good and steady and firm. Here's my burette that I'm going to use. It's always good to check these things a little bit first. Like put in a little water or something like that and make sure that it actually comes out and there's not a blockage on here. Okay, so here's this thing ready to go. And now here's lab practice. I'm gonna prep this thing. So best practice would have you do a rinse of your titrant into this, and then you fill your titrant. Okay, this also helps you if there's ever a tiny little plug of water, which you might have because I just told you that you need to check to make sure this works. So I would fill it with water, which let me just do that off screen over here. Or maybe not even fill it with water, but I kind of wish that I had some sort of, okay. So I put a touch of water in here. You can see the height. So I'm just checking it. I see water coming through it, so I know that it works. What I can do now is I can hold it off to the side and I can pour out. Okay, so I have a tiny little plug of water right here, and if you think about it, that would dilute my data, and I don't, or because it would dilute my titrant, so I don't want to do that. Okay, the blue, this is just food coloring inside of water. This is my simulated titrant. Okay, so the iodine stuff. Whenever you're going to fill into one of these, I have it stopped right now, and I'm going to take it down. Don't have it up in your apparatus on your ring stand. You don't want to be pouring anything above your head. So one person's going to grab, they're going to have some container that has a lip on it so that you can pour. This is me doing my rinse. So I'm just putting in a little plug. Okay, I don't need to waste, this is probably too much. I don't need to waste my titrant here. But what I can do is I can move this roughly horizontal, and I'm starting to spin it, and I'm trying to wet the sides of the burette, and I'm going into my cup here. Okay, so I've now wet all the sides of the burette with the titrant, and then I'm also going to allow some more of that solution to go through here. Okay, so I'm totally rinsing the inside. All right, so now that is done, now I am ready to actually fill this. And so I'm going to come in here. You should always fill just below the top. Okay, don't try to hit it squarely. I'm like 0.3 or 0.4 milliliters lower than the top. I got kind of lucky that I hit it pretty well. Don't try to hit it exactly. Just take the measurement of what your start point is. Then you're going to clamp it in here. Okay. So I have my clamp in here. So here's the tip. Here's the surface. This is my simulated sample. Okay. You want enough sample in here, like liquid-wise. You want enough sample so that you can stir it around pretty easily. You don't want too much so that, because you are about to put more liquid in here as well. If you think about the way that the titration works, you can always add DI water to your sample once you've put it in, and that doesn't change the number of moles of sample that are in there. So if we go back to this idea with these things where I have a certain number of moles, parts of sample in there, just adding DI doesn't change anything. So you always have a little freedom to adjust if you need, but here's my amount. What I'm gonna do is I'm gonna adjust the height of this here. I'm gonna go extra tall for a moment, and I'm gonna slide this under, and I want the tip of this to be just under the lip of the Erlenmeyer, okay? All right, now the other thing that you need to do though is you never want to be trying to look for a color change. So your solution is going to be clear and you're looking for a dark blue-black change. So you want to put something under it so that you can see it well. All right. Now, somebody's going to take the measurement up above of the initial quantity. Your eyes should be at the level of the burette so that you can get a good measurement. I am right-handed, which means I'm going to hold this with my right hand and do a little stirring as I'm doing my titration. My non-dominant hand, my left hand, is going to be the one that turns this, okay? So I'm going, and then I don't know if you could see that very well, but what I did is I opened the valve, and then I'm always kind of turning the valve in one direction here. What am I doing? I'm doing clockwise. So you can open it up, turn it. When you start to get close, you'll know because you'll start to see a little bit of color changes happening that don't persist because of that indicator. When you start to get close, I recommend that you start doing these half turns. And so it's just sitting here and you just go boop, you just do a half turn and it puts a tiny little squirt in there. This is kind of that mid-range amount that you're adding before you actually are going drop by drop. When you really think you're getting close and you're ready to be going drop by drop, you are going to just try to ever so slightly adjust it so that it just barely seems like it's open and you're doing little drops. And whenever you see it do that persistent color change, you turn it off and you can take this out and get your final reading from up above. And then you use the difference in volume to run your calculations. So on day one, just to reiterate, on day one, you're going to grab one of these things, you smash it up, you figure out how much powder is in there, how much vitamin C, and then you're going to load up a sample so that you think you're going to use 25 milliliters of your titrant. And then let's say in this hypothetical at the end of day one, I have used 17 milliliters of my titrant. What I do is I assume that this was correct because it came from something I made. So I assume it's correct. And I recalculate what is the concentration of this stuff here, okay? And then on day two, I'm going to use a known concentration of that titrant. And I'm going to fix a sample from something interesting, like an orange or some kale or something like that. And day two involves a lot of sample prep. And the titration goes pretty quick on day two. So I think that's probably good for now. For an intro, that'll get you started. We most certainly will have a lot of questions that happen on lab day itself. But if you can come in and you walk up to the scale and you weigh one of these within the first handful of minutes, you're in good shape. So I really want you to sit down and play with the calculations so that you know what's going on. Here's the reactions that we're doing. You need to know that it is 1-to-1 between vitamin C and I2. You need to know the molar mass of this. Okay, this was in molarity. Okay, 0.005 molar, and of the I2. I will tell you, we have been off by a factor of 2 in some years. with this stuff. This stuff is really finicky, which is part of the reason why we go about it this way. Okay. All right. Thanks, guys.